Hello everyone. Today I'll be going over problem 11 from Control's homework. The problem asks us to solve for phase and gain margin of this given block diagram uh, with the given k value. So to do this problem, first begin with setting up your g of s and h of s. Your g of s is the block value, which is in your forward path. H of s is going to be the value that is in the block for the feedback path. Once you have these determined, multiply them together, and before you expand it, just replace s with j omega at this step because you don't want to make a mistake when you're expanding and plugging j omega at that time. So it's just good at this time that you should replace s with j omega. Once you do this, it's just some algebra. Expand this form into getting an equation. The equation you're going to end up with is going to have an imaginary and real part. Um, at this point, I would say it's a good thing that if you can mark your imaginary and real part because it's going to help you not make a mistake when you're going to be doing other calculations. First of all, you're going to be solving for your phase crossover frequency. Uh, since it's a phase, you're solving something for the phase. You have to do it's going to deal with the imaginary part of the equation. So you take the imaginary part of the equation that you just found and solve for omega. The j will drop out, and you should end up with some number for omega. You're going to use this omega to find your gain margin. In your gain margin equation, you're going to have the equation that you found earlier from the block. But now you're going to be replacing your omega with the crossover frequency that you found from your this equation right here. And the number that you're going to get for this, you're going to divide that. You're going to do 1 divided by that. So the number you will end up with is going to give you the value in dB for your gain margin when you use the 20 log formula. Once you have this, then you can compute your phase margin. This is probably going to be the part of the problem which takes some time because you would have to do calculations to sketch a body to get an idea because to find the angle you're going to have to find um, your frequency and your angle. And since I don't have too much space in here and it's going to take a lot of calculation to do, I did this in MATLAB to show that this works. So once you have your transfer function set up, simply do Bode for your transfer function and you should have a figure. In your figure, by the way, something that helps is go in your figure properties and then go to selection style. I think it's not showing me those options anymore. Anyways, so what you do when you are in figure properties, you select your state error and margin error or minimum margin, I believe that's what it is. You select those options. It's going to be in like this little drop menu that comes up when you do a right click, and that's going to give you these points that you can use to see like what your if your answer is correct or not. And as you can see here, in your phase margin, it shows that it's negative 20.3, and actually that's the right answer for this, and it tells you your frequency. As well for the gain margin, you can see that the gain margin is negative 6.38 at that point. Going back to where we were. All right. If you do your calculations, you would see that you will end up with negative 20.3. Now, this problem, again, not impossible, just a lot of math that you have to do. MATLAB is just there so you can verify that what you did is right. Um, I hope this problem helped you to figure out how to do phase and gain margin. Thank you.